All right, so now that we know how humans and human society have developed with our ability to manipulate these elements, these minerals, let's talk about how we actually get these minerals out of the ground and use them. All right, so now we're going to talk about ore. To attain metals for an industrialized society, we mine ore. Ore is not the end product we want, right? Instead, it's the original rock. It's the ore rock, the ore deposit that contains significant concentration of native metals or ore metals, right? So we want lead. That's the metal we want. But in order to get lead, we have to mine ore, the rock that contains lead, which could be galena or something like that. Okay. So ore minerals, also called economic minerals, they're those minerals that contain metal both in sufficiently high concentrations and in a form that can be easily extracted. So we want metal, we have to mine ore. So how do ore deposits form? Well, ore deposits do not occur uniformly throughout the rocks of the crust, which is really, really good for us because these minerals occur at such low concentrations, right? If they were spread out evenly along Earth's crust, it would be very difficult for us to get them. Instead, they're often concentrated in small areas, right? So they form in ore deposits. Now, these areas of concentrated ore can form in lots of different places. The first we're going to focus on is magmatic deposits, those deposits that form in magma chambers. Okay? So we've already talked about how as magma cools, some minerals are going to crystallize first and settle to the bottom of the magma chamber. Sulfide ore minerals are some of those minerals that do that. They crystallize early, they settle to the bottom of the magma chamber, and they accumulate there, which means that if we want to mine that sulfide ore, we just need to find the bottom of a solidified magma chamber because they're concentrated down there at the bottom. This also happens in hydrothermal deposits, right? Anywhere you've got water circulating through Earth's crust, where it's coming into contact with magma or other really hot materials and it's heating up. So you get really hot water circulating through Earth's crust, hence hydrothermal, hot water. This hot water, as it flows through Earth's crust, is going to pick up more and more dissolved metal ions. And when that water then flows to areas of a lower pressure or lower temperature, or maybe a different acidity or different availability of oxygen, so on and so on, a different environment, those dissolved metals can come out of solution and form ore minerals. Right? So they precipitate in fractures and pores, creating a hydrothermal deposit. Right? Gold can form this way. Right? You often find gold near volcanoes because of hydrothermal circulation of really hot water that has a lot of gold dissolved in the water, and then that water moves into a colder place of lower pressure. That gold can precipitate out and form those quartz veins, or sorry, those gold veins often associated with quartz veins. Another place that ore deposits can form is in submarine vents. So submarine vents, this is hydrothermal activity that occurs on the ocean floor. And on the ocean floor, often near mid-ocean ridges, right, often where you have magma coming close to Earth's surface, there's going to be hydrothermal circulation within the ocean floor, within the ocean crust. And as that hot water escapes out of the crust, it comes in that hot water that contains a lot of metal and a lot of sulfur. That hot vent water is going to vent out, come into contact with cold seawater, and then precipitate out as solid on the seafloor. So here's an image of a real hydrothermal vent. They can become as tall as skyscrapers on the ocean floor, right? Those ores as they precipitate out on the ocean floor, which is one of the reasons deep sea mining is becoming a very popular idea right now. I think it's the mining of the future.